Hello everyone, welcome to General Chemistry Tutorial. Today we'll be looking at a question, and the question is given 0.035 mole per dm cube. Mole per dm cube can also be represented with the capital letter M. So given 0.035 mole per dm cube acetic acid solution with a dissociation constant represented with K subset A is equal to 1.75 exponential minus 5 mole per dm cube. What is the concentration of the hydrogen ion and the pH of the solution? Whenever you see a K subscript A, it represents the dissociation constant of an acid when it is in water. The tendency of a water to lose its proton. So it refers to as what? The dissociation constant. Solution to the problem X. Answer. Given that the concentration of acetic acid, which is chemical symbol or chemical formula, is CH3COOH. Given that this concentration of acetic acid is equal to 0.035 mole per dm cube, and the dissociation constant K subscript A is equal to 1.75 exponential minus 5 mole per dm cube. Then acetic acid is one of the examples of a weak acid. So it does not dissociate completely. That is, it does not ionize completely. Therefore, it ionizes partially in water. And when acetic acid ionizes in water, it gives a basicity, one basicity. And we have it to be CH3COO negative plus H positive, which represents one basicity. So the dissociation constant Ka will be from the equations above. We can have it to be dissociation constant or an equilibrium constant. We have it that the numerator will have the product side, the concentration of the product side, while the denominator will have the concentration of the reactant side. Therefore, we'll have it to be Ka is equal to the concentration of CH3COO negative, then and times the concentration of hydrogen ion, divide by the concentration of the acid. When the concentration of the acid is slightly small, therefore we can have it to be the concentration of the conjugate base is equal to the concentration of the hydrogen ion. So the dissociation constant Ka, which is going to be equal to the concentration of hydrogen ion times the concentration of hydrogen ion. Since the concentration of the acid was small, and therefore the anion is equal to the cations. You have it to be that. So Ka is equal to the concentration of hydrogen positive and the concentration of hydrogen positive divided by the concentration of the acid itself. Therefore, we can also have it to be Ka is equal to the hydrogen ion concentration squared divided by the concentration of the acetic acid. Then let us make the concentration of hydrogen ion positive squared to be equal to the subject of the expressions above. Then we have it to be concentration of hydrogen ion squared is equal to the Ka times the concentrations of the acetic acids. We are interested in making the concentration of hydrogen ion the subject of the expressions, and since it has a square there, we can eliminate the square by taking the square root of both sides. Therefore, have it to be hydrogen. The concentration of hydrogen ion is equal to the Ka concentration of acetic acid, all in bracket, raised to the power of 1 over 2. Then let's substitute our variables or values as well. So have that the concentration of hydrogen ions is equal to 1.75 exponential minus 5 times 0.035, all in bracket raised to the power 1 over 2. Then it will be equal to 1 over 2 is in the laws of indices is equivalent to square roots. Is equivalent to square roots. So we can either use 1 over 2 raised to as an exponential 1 over 2, or we can either use what? Square root. We are all talking the same thing. Therefore, if we take the square root of 1.75 exponential minus 5 times 0.035, we're going to have it to be there. The concentration of the hydrogen ion is equal to 7.83 times 10 raised to the power of minus 4. Thank you so much. Then we also have to calculate the pH of the solutions. We have find the concentration of the hydrogen ion, and we are interested in finding the pH of the solution. And we understand that the pH of a solution can be determined by getting the negative common logarithm of the value of the hydrogen ion concentrations. Therefore, have it to be pH is equal to negative logarithm of the concentration of what? Hydrogen ion. And we have gotten the hydrogen ion, the concentration of the hydrogen ion to be 7.83 times 10 raised to the power of minus 4. So the pH is going to be equal to negative logarithm, all in brackets, 7.83 times 10 raised to the power of minus 4. And let us solve using our logarithm ideas. We said that whenever we are multiplying, logarithm is equivalent to what? Summations of the logged numbers. Therefore, have it to be equal to minus log 7.83 plus bracket minus log 10 raised to the power of minus 4. Then from our logarithm, we understand that whenever we have minus log 10 raised to the power of minus 4 is equivalent to what? 4. Therefore, have it to be 4 minus log 7.83, and we have it that is going to be equal to 4 minus 0.9. That is because log 7.83 is equal to 0.9. Therefore, 4 minus 0.9 is equal to 3.1. Thank you for watching. Please click on the subscribe button to be notified whenever further chemistry related questions and their solutions are being posted. Thanks for watching.